In this example, I am going to show you how to solve the equation that look like the quadratic equation. Now, first remind ourselves that the quadratic equation look like this, where A, B, C are a number. Now, what makes this is the quadratic equation is a square. The square is tell us that I have a quadratic equation. Now, this is a standard form of the quadratic equation. We have three terms. Look, this term here, with the x here, this x here has power 1. This x here has power 2. This term, this x here, this power here is twice as much as this one. That's another thing that make this is quadratic equation. So I want to solve this equation. Look very nasty. But we used to have the base just x right here. This is our base is just x. Our base here is more than x. It's x minus 2. So and we've observed that if you look at this guy here, regarding of the minus 2, here your base, here your base, here your base, to the power 1. So in other words, if you compare this equation to that equation here, they look very similar. They look like the quadratic equation, except your base is nasty. So in other words, to solve this equation here, it's the same thing to solve this equation. So this method I'm going to show you is called substitution method. So I let k equal to the base, because this base here has smallest power, so I'm using the smallest power as k, so k is x minus 2. Now if k equals x minus 2, I square the k, therefore x minus 2 squared is k squared, right? So all you have to do is go back here and replace this base here by k squared. So I replace this here by k, whole thing here by k squared, plus, gives me minus 3 times k plus 2 equal to 0. So I substitute the base by k. Now we solve for k. To solve for k, I'm going to factor out because it's a plus sign, so I have same sign. 2 is 2 and 1, so therefore it's my factor. And solve for k, I have k minus 2 or k minus 1 equal to 0. This case here, I plus 2 both sides, k is 2. Right here, I plus 1 both sides, k is 1. Now I'm solving for k, but the question they asked us to solve for x. So to solve for x, all you have to do is substitute the k back into your equation. So now if k is equal to, and we know that k also equal to x minus 2. So I know that k equal to 2, and I know that k also equal to x minus 2. So therefore, we can conclude that 2, this 2 here, is equal to x minus 2. Because 2 is k, and k is equal to that. So now to solve for x, I plus 2 both sides. Therefore, k is equal to, x is 4. That's my answer. Now, if k is 1, and we know that k is also equal to x minus 2, because we left that in the beginning here. So therefore, 1 has to be equal to x minus 2. Just the same things. K has a different name. So I just connect them together. So I plus 2 both sides. So therefore x equals to 3. Here is our another answer for x. That's it. Let me show you another example. Hopefully this time you will see it clear. Alright, I want to solve this equation. Now before I do anything, I have to make sure this equation here look like this equation. So I'm going to rewrite this as x minus 5 to the 1/2 plus 6 equal to 0. Now I want to check to see if this equation here behaves like the quadratic equation. If it is, then we can use the same method that we saw for this equation to solve this equation. So this power here is 1, is here, this power is 1/2. And you see that this power here is twice as much as that power. So the same here, even though I don't have a square. So this means this equation here behaves very similar to this equation. We do the same thing. We solve for x exactly the same way we solve for x for this equation. However, we're going to use the substitution method. Once again, I let k equal to the x that have the base, they have the small exponent between 1 and 1/2. This one has a smaller exponent that have equal to x squared. You can let this equal to anything you want. You can call whatever name you want. So in this case, it's called k. Now, if I let k equal to x to the 1/2, therefore k squared, I squared both sides, 1/2. We know that a to the inner to the m is a to the inner times m. So I take 1/2 times 2, which is x to the 1. So now I'm go back and rewrite this equation in terms of k. I know that k squared equal to x to the first power, so I put k squared minus 5 times x squared, but x squared is k. We let that equal to k plus 6. So you see now this equation here look exactly similar to this equation, but now we have k instead of x. So now we solve for k and we'll factor out if possible. If I cannot factor out, then you have to use the quadratic formula. I have k here, k there, plus same sign actually, because this plus sign has the same sign. 6 is 2 and 3, so make sure your factor is correct. Minus 3 plus minus 2 is minus 5, minus 3 times minus 2 is 6. So you have k minus 3 equal to 0, or k minus 2 equal to 0. In this case here, plus 3 both sides, k equal to 3. Over here we do the same thing, and plus 2, k equal to 2. Okay, now when I get to here, I'm not done yet because I'm looking for x not k. So now all you have to do is, here is k. Now to solve for x, we know that we let k equal to x to the 1/2. In the beginning here, we let that happen. We let this. So, and we know that k also equal to 3. Therefore, 3 has to be equal to x to the 1/2. Okay? If k equal to 3 and k also equal to x to the 1/2, therefore 3 has to be equal to x to the 1/2. This is the same thing as x to the square. So to solve for x here, you just have to square both sides. So you have 9 equal to x. This is one of our answer. For another answer, we go to here. I know that k also equal to 2. And we know that k is also equal to x to the 1/2. So therefore, 2 has to be equal to 1/2. So when you square this both sides, I have 4 equal to x. This is my another answer.